Hello and welcome back everyone. Today we'll do section 1.5 on circles. So quick definition, circle is a set of points that are a fixed distance from a fixed point. That fixed distance is the radius r. Fixed point we'll call the center, usually denoted HK. Now to get the basic setup for the equation of a circle, we're going to let x, y be some point on a circle. With the properties listed above, radius r, centered on HK. So, time for another lovely, beautiful work of art. So here is Hotel Kilo in the middle there, and here is some arbitrary point, X-ray Yankee. Here is our radius. To get the equation for this, all we have to do is call up our buddy Pythagoras. We'll drop down a perpendicular there. So we have x minus h as this distance here, and we have y minus k as this distance. Now, it doesn't matter if the xy were up here or down here. If these were both negatives, remember in Pythagorean we're going to square them anyway, and the result would be the same. So leg squared plus leg squared equals hypotenuse squared, and that's the general setup for a circle. The unit circle that you'll work with quite a bit in your next course, centered on the origin and has a radius of 1. We don't do too much with it in this course. Again, next course you'll do quite a bit of work with that. So let's see if you can follow this setup and write the equation of the circle with the properties. Radius of r equals 4, centered on -5, +2. Okay, go ahead and pause the video, see if you can write that equation, and we'll catch up. Okay, welcome back. So x minus our center point, x minus a -5 squared, plus y minus the center value of 2 squared equals our radius squared. So don't forget this 4, the radius is also squared. Only a little bit of simplifying that we would typically do with that. X plus 5 squared plus y minus 2 squared is 4 squared. You might see it as 16, you might see it as 4 squared. Either one of those is just fine. So then we use that knowledge to sketch a graph. Again, while we're doing this remote, since I can't pass out printed handouts with a nice, neat, pretty grid on them, you'll be kind of doing your best to scale it in. But we'll sketch the graph for x minus 3 quantity squared plus y plus 2 quantity squared is worth 25. So I'll write down the information that I know about it so far. So we know the center is at 3, -2. Watch those signs. Remember, x minus 3, y plus 2 is the same as y minus a -2, and a radius of 5. I'm going to assume that not all of you have one of these sitting at home, so I'm not going to require them, of course. But it'll help me give you at least a little bit better of a sketch. So 3, -2, so to the right 1, 2, 3, down 1, 2. And then 5 in each direction usually gives you a sufficient amount of points to sketch in the circle. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So just 1 point in each compass direction is enough. 1, 2, 3, 4, and 5. And 1, 2, 3, 4, and 5. So there's a halfway decent sketch of the circle described. Next, we'll take a look at the idea of intercepts. As far as how many intercepts a circle can have, this one we don't need a lot of detail. It's possible that a circle will have no x-intercepts and no y-intercepts. It's possible it will have only one of those two, either one x or one y. There's a few different ways to have 2 intercepts. Sort of a common one would be that. Could have that on the y-axis as well. Or we could just touch each of the axes. It's possible then, of course, to have 3 intercepts. Just slide these over until they touch. So basically 2 on one axis, 1 on the other. You can picture that the other way as well. 2 on the y, 1 on the x. And, well, here's one that has 4 intercepts. 4 is the max. So there's your drawback to the little stamp pad. All right. If I'm asking for intercepts of a circle, I'm looking for exact values, not decimal approximations. So we'll do x minus 4 squared plus y plus 2 squared is worth 36. So I can see from this that we have a radius of 6, and we haven't shifted 6 or more units away from the origin on either the x or the y. So this one I expect to see 4 intercepts. So the x-intercept just like in linears or quadratics or anything else that you've worked with so far, if it's an x-intercept, it means y is 0. So x minus 4 squared plus 0 plus 2 quantity squared is 36. So x minus 4 quantity squared is worth 36. Minus 2 squared is just 4. So x minus 4 squared is 32. Square to both sides. Plus or minus on the side with the square root. Or, I'm sorry, they both have square root on the side with the constant. 32 has 16 as a factor. That is the biggest perfect square we can nab from there. So x minus 4 is plus or minus 4 root 2. So just add 4 to both sides. So x is 4 plus or minus 4 root 2. And we just turn those into ordered pairs. So 4 plus 4 square root of 2, 0. 4 minus 4 square root of 2, comma 0. Y-intercepts. Again, just automatically, if it's a y-intercept, we know that x is equal to 0. So we have 0 minus 4 quantity squared plus y plus 2 quantity squared is 36. So 0 minus 4 is negative 4. Negative 4 times negative 4, positive 16. So 16 plus y plus 2 quantity squared is 36. Subtract 16 on both sides, so y plus 2 quantity squared is worth 20. Square root of both sides. Plus or minus on the side with a constant. 4 is the biggest perfect square we can factor out of that 20. So y plus 2 is plus or minus 2 root 5. And we'll just subtract 2 on both sides. So y is negative 2 plus or minus 2 root 5. And we turn those into ordered pairs. 0 was the x value. Negative 2 plus 2 root 5 was one of the y values. Negative 2 minus 2 root 5 was our other y value. X value still at 0. So there's all of our intercepts. Alright, so we have you all try one out. Same directions, find all intercepts. And we'll do x minus 2 squared plus y plus 9 quantity squared equals 16. Alright, so give that a minute, see if you can find all of the intercepts. Okay, welcome back. Hopefully you have the video paused and have your answer in hand now. So x-intercepts, those only happen when y is 0. So x minus 2 squared plus 0 plus 9 squared equals 16. X minus 2 quantity squared plus 81 is 16. Subtract 81 on both sides. X minus 2 quantity squared. And now we're into negative territory. I can't have an x-intercept that has an I involved. My next step would be to do the square root of both sides. So we have no x-intercepts. Remember, an x-axis and a y-axis, those are just real number lines. So if we're kicked off of the real number line, we're not in the xy plane anymore. Now, that should make sense as far as the radius and the shifting of the center of the circle. Our radius, you can see here, is 4. 4 squared would get us to the 16. And our y's shifted all the way down to a negative 9. We don't reach far enough to cross the x-axis. We move down too far. Y-intercepts, however, we do have some of those. We just shifted to the right 2 units, and we have a radius of 4. So we will have 2 y-intercepts. Y-intercepts happen, of course, when x is 0. So negative 2 times negative 2, positive 4. So 4 plus y plus 9 quantity squared is 16. Move the 4. So y plus 9 quantity squared is worth 12. Square root of both sides, plus or minus on the side that has the constant. And 12 will turn into a 4 times 3. So y plus 9 is plus or minus 2 root 3. Subtract 9 on both sides. Y is negative 9 plus or minus 2 root 3. And then we turn those into ordered pairs. So 0 for the x, negative 9 plus 2 root 3. 0, and negative 9 minus 2 root 3. So the next thing we work on is what happens if they ask us to graph this thing, but they don't start us in this nice, neat, pretty easy to work with. They call it standard form that we have been working with. If we start in general form instead. So we'll do x squared plus y squared minus 14x plus 8y plus 49 is 0. So this is in, again, what we call the general form. And our goal is to get back to standard form. That'll help us sketch the graph. So first thing I do is just sort it. I'll put my x's in one spot. X squared minus 14x. And I'm just going to leave a little bit of space. I'm going to put another term there in a moment. Regroup my y's. Y squared plus 8y. And we'll just move the 49 to the other side. Leave a little room, equals negative 49. So our goal, we want it to look like x minus h squared plus y minus k squared equals r squared. We want perfect squares, so sure enough, just like you guessed, completing the square. Leading coefficient is already 1, so we'll do half of negative 14, negative 7. Square the result. That's positive 49. And if I add it to one side, I have to add it to the other. I'll do the same thing with my y's. I'll squeeze a little plus sign in front of this y squared, since it's not 49 times y squared. It's 49 plus y squared there. Half of 8 is 4. 4 squared, 16. I'll add 16 to both sides as well. So now, a little factoring. X minus 7 quantity squared plus y plus 4 quantity squared is equal to 16 is 4 squared. So I know my center is at 7, negative 4, and we have a radius of 4. And for this one, I'm going to have to sort of scale it a little bit, since I only go 10 in each direction with my little grid here. We're going to scale the x and y's by 2. Since we'll be at 7 and want to move to the right 4, we'd have to go all the way to 11. Alright, so I'll put my center on there. So 7, negative 4, so 2, 4, 6, 7, and negative 2, 4. And then we count 4 in each direction. So 2, 4, 2, 4, 2, 4, and 2, 4. So this was one of the circles that had exactly one intercept.